Hey everyone, I'm a small lizard, and we continue with our analysis of using the Venn diagram to explore conditional probabilities. So what is the idea of conditional probabilities? Alright, so let's say we have event A and event B. And let's first assume that they have an intersection where it's possible for A and B to both happen at the same time. Now, the thing is this, when we look at probability as a whole, we're always comparing it to the whole world, right? We're always comparing it to 1, right? Because probability of all outcomes must be 1, so we're always comparing relative to that. The difference is this. Let's say we already know that one of the conditions is already satisfied, aka one event already occurs, and we already have knowledge of that happening. What's going to happen is this, all right? For example, let's say we know that, all right, or rather we have that A is raining, or rather John going out. And B is it is raining. All right, then of course, let's say we have the probability that John goes out given that it is raining. So you notice that we know that it is already raining because we are given that it is raining. So what's going to happen is, since we know that it's already raining, then the probability is going to be different, right? It's because now, instead of comparing it to the whole world, we already know that B is happening, so we're going to look at just the B only. Right, so we're just going to compare it relative to the probability of B. And hence we have the formula where if you have PA given B, so this vertical line is basically given, so A given B. And it is simply equals to, all right, since we know that, all right, look at this example again. John goes out given that it's raining. We know that John goes out on a rainy day, which means that it is raining and John goes out. Now the difference is, since we know that it's already raining, instead of comparing it to the whole other possibilities such as a sunny weather or a hailstorm, for some reason he still wants to go on a hailstorm, we're just going to compare it relative to the rainy day, PB. Alright, and we can actually extend it to a number of cases, right? So where n is the number of cases where A intersect B over number of cases of B happening. Alright, because instead of comparing to the whole world, we narrow our comparison and we make it relative to the condition that's already satisfied. Alright, so that is the logic behind conditional probability, and we're going to see that in action with this example right here. A committee of 8 personnel is to be formed from 3 departments A, B, C. There are 3 there's 3 people in department A, 5 in B, 7 in C. Alright, so there's a total of 15 people. What's the probability that exactly one person is picked from department A given that? Alright, so conditional probability, one very, very common phrase is given that, because this signifies that event is already satisfied. Alright, so with this we know that we have to apply conditional probability, and the condition is that 4 from department C is picked. So what are we going to do? Alright, so remember the formula. So if n, one person from A intersecting 4 people from C over, now because the condition that is 4 people from C is being picked, so we're going to find a lot of cases of where 4 people from C. Alright, one person from A, 4 people from C, we still have 3 missing spots, they have to come from B. Alright, so first, one person from A, there's 3 people from A that's in department A, we just need 1 of them, so 3 ways. 4 people from C, we have 7 on them, 7 choose 4. You want 3 people from B, and there's 5 of them, 5 choose 3. So that is 1 person from A and 4 people from C. Now, total number of cases that we're going to find in the event that is satisfied, which is the 4 people from department C. So again, 7 choose 4. Now we have 4 people left. We can pick from any 4 from A or B, because now we just want to find 4 people from C only. So there are 8 people in department A and B. When we want to pick 4 of them, is simply 8 choose 4. Alright, and then this would leave us with 3 choose 7. Alright, so one trick is, we notice that there are 7 choose 4 on both sides. We can just cancel them out. Now, the answer is 3 over 7, right? Now, let me just compare it with, let's say, the condition is not satisfied, or rather it is, we don't know whether is it true or not. So in that case, we're going to find one person from A intersecting 4 people, I'm very lazy to draw, right, the word people, so 4 people from C over total number of cases, total number of ways, right? Because now there's no more condition that's satisfied. We just want to compare it to the whole world instead of just the instead of just relative to the condition. All right, so again, we have 3 times 7 choose 4 times 5 choose 3 as from part I. Total number of ways, since there's 15 people in total, we just need to choose 8 of them, so 15 choose 8. And the answer will come up to 70 over 429, which you realize it is actually smaller than 3 over 7, all right? Or in fact, it's not even equals to 3 over 7, all right? So you notice that there's a very big difference, and there may be a difference when a condition is being satisfied. Of course, you start to realize that, hey, sometimes even with that happening, it doesn't affect anything. For example, let's say you flip a coin and you roll a dice. And you notice that even if, let's say, you roll a dice and you flip a coin, sure, you can have an intersection, but the probability might still remain the same, all right? And we notice that that would actually mean something, all right, when it comes to looking at the probability instead of just looking at the number of ways. All right, so there we have it, the idea of conditional probabilities and it being an action.